Hello, everyone. You're welcome to today's lesson on MATLAB for Engineers, brought to you by the GAD Academy. I'm Martin, and I'm your moderator for today's lesson on scripts. Today, we're going to look at how to create simple programs. So far, we've been working with the interactive window or the command window in MATLAB, and we are going to move now into creating our own programs or program files. So we'll look at programs and algorithms. Then we'll look at MATLAB scripts and where they fall, and it will look at some input processing and then output tools used to build simple programs in MATLAB. So far we have used MATLAB software in an interactive way. We have used it almost as a calculator. So we quickly type in exactly what we want, and then there and then we receive a response. But we have no way of storing what we did beyond, because right after the command window is cleared, everything done is gone. However, for just normal computations or using MATLAB like a calculator, that was fine. Now, if we need to build programs that larger programs made up of several lines of code for computing or performing certain tasks, this becomes unsustainable. Right? We need to be able to build programs that we can store, reuse, and so on. So when we need to use several steps or build complex programs, or we need more, we need to be able to store our files, then we'll build a program. Right? Instead of using MATLAB interactively, we need to build programs or program files that store the lines of code for us. Now let's talk about algorithms. So if we revisit our ideal gas problem from the first lesson, where we were trying to estimate the concentration or the moles per volume of a gas, given temperature, pressure, and then the gas constant. We, if now this is a problem that can be solved on paper with a calculator, and in everyday math, we solve problems like this. Now, if you are faced with a problem like this, you usually go through a number of steps or brainstorm before you execute your solution, right? Before you write out a solution. So you first try to maybe identify parameters or variables present. You convert units and make sure all units are consistent. You may then write out your formula or the equation of interest and try to rearrange it into the form that you need. Then you substitute your values in there, and then you compute your final answer. You may even then decide to format the answer, maybe for decimal places as such. Now, these steps you've taken, the idea or the sequence of steps taken is what we call an algorithm. So algorithms are just sequence of steps needed to solve a problem. You can think of it as the method or the plan, the game plan towards getting the answer for this particular problem. So if we think of it that way, then it becomes clear that we use algorithms every day in our daily lives, not just for programming. Whenever we have any decision to make or we have anything to do, any task, we think through the steps we need to take to ensure that that task is done or completed successfully. And that is our algorithm. So it's essentially a recipe for doing anything. So a food recipe is also an algorithm that a cook will follow to prepare a meal. Now, just as um, chefs need recipes, computer programs also require algorithms to execute or perform certain tasks as instructed. So given any particular task, we need to, it's up to the programmer to come up with an algorithm that can solve that problem. Now, documenting the algorithm in any particular programming languages is what we call a program. And so the program is the actual instructions being placed or documented in a file that can be run to give you a response or an output. So the program takes an input, processes it through the steps, and then produces an output. Now, every MATLAB script you write is a program. So you can think of it as the algorithm is the plan, and then the program implements the plan. So to find the area of a rectangle, for instance, you enter dimensions, you multiply length by width, and then you display results. So that process is your algorithm. And then when you document it in a programming language and pass it to MATLAB to carry out, that documentation or that file is your program. Now that we've seen the difference between a program and an algorithm, let's talk about compilers and interpreters. Now, there's a difference between the typical programming language we build programs with, or the code we write, and what the computer actually is able to um, understand and implement. So what happens is we deal with high level programs or languages, and these are usually written in human readable form. The languages are close to for human language, right? So it's easy for us to understand and then instruct the computer. However, this version of instruction is not useful for the computer just yet. The computer cannot understand that. So another program is needed to translate the human code or the code you write into machine language. Machine language is usually just numbers, zeros and ones at the core. Now, those programs that do that translation are called compilers, and they do that by creating a different file which contains the translated code based on the source code you wrote. And that file is what is executed to give you so it's called an executable file. And when it's run, the computer then follows the program in there to produce your output. So it's essentially the same instruction, but written in different languages. One is the version you understand. The other is that version you produced or understood, translated into machine language so the machine can execute it. Now, programs like MATLAB do not use compilers, Python, and so on. They are interpreted languages. So what interpreters do is instead of uh, translating the entire block of code inside a program into a new executable and then running everything, interpreters go through your program one by one and translate every line and execute easy to. So they do not create separate executable files, but they move through the program line by line and then translate and run the code. So MATLAB is an interpreted language, and therefore the program files created or the code files created are termed as scripts. True programs or programs are compiled files rather. However, the language is loosely used, so even MATLAB refers to scripts as programs. So you will not go wrong by using any of those terms. Now let's talk about scripts. So a script is a text file with a .m extension, and this extension is an extension for MATLAB files. Right? So it's an extension containing MATLAB commands or instructions, or basically your code. And then when MATLAB executes the commands, it's able to interpret your program and then execute or deliver the results. So MATLAB, as we've established already, runs from top to bottom. So the program is also interpreted in that order. So to open a new script, you just need to click on New Script on the Home tab at the top of the command window, and that should create an editor. It should take you to the editor window where you can type in your code. So the script is created using MATLAB's own text editor. So an editor is just a place for you to organize and create code. Right? It just stores your code and allows you to edit and debug your code before running it. So let's head into MATLAB. Then So over here on the home tab, you can see new script. So if you click on this, it should quickly take you to the editor. You can see the editor tab activated. And here you can type in whatever lines of code you have. You could also go to new instead. You would come here and then click on script, and that should open as an editor for you. And on our side script, there's also live script. And the difference between the two is live script is a bit more interactive in the sense that the results are displayed as you code. And so it's actively or run on the spot without requiring the user to run or rerun the program anytime they update the code. So as you update your code or your program, it it interprets and runs your program and then displays results for you as you go. Whereas for the normal script, you have to build the program, and then when you want to view results, you need to run it yourself. So if you go and update certain parts of your code, or you make modifications to your old code, you only see the latest result when you run the program. So we're going to create our first script. Now, one thing you notice when you click on the scripts, a new script, is the command window or the MATLAB interface changes, right? The environment changes, the order changes because of the editor. Now the open tab untitled, so that means because the file has not been saved. So this is supposed to create a file, but because the file has not yet been saved, it's untitled for now. The current folder and the details section are still in the same spot. However, the command window is minimized, and depending on your settings, it could even be smaller compared. Then you have the workspace coming down here, and then the editor taking the larger portion of the screen. Another thing to notice, as you type in code, the editor numbers your lines of code. Right now, this is very good for documentation and for tracking your code. It's also good for troubleshooting whenever you have errors and MATLAB wants to direct you as to where the problem might have occurred. It uses these lines or these line numbers. So it's important to take note of them. Then on the right side, the far right side, you see this symbol here that shows you the status of every line. So if I was to enter something here, you see that this check is still there at this point because I have not yet made any errors or done anything that MATLAB wants to prompt me about. So this is MATLAB's way of sending you messages every now and then when you type in new code. So assuming you make an error there, the color changes and the symbol also changes. There's one for caution or warning. There's another for error, which is usually red. The caution is usually yellow. And that is MATLAB's way of tracking different lines of your code. And that is very good, helpful for debugging your code as you build it. So you're able to see problems quickly and then rectify them. You also note that if you create a script, so let's go ahead and save this untitled. So we come here, we hit save, and then let's call it demo. Now, once we hit save, we see that in the current folder, we have the demo file created over there. And so it automatically saves to your current folder. However, in the dialog, you could have saved it somewhere else. So if I want to edit the file name, I could go save as and then change the location to anywhere else on the PC and then do that. It's just that when you are running, MATLAB needs to add that directory to the path before it's able to access the file and then run. And that may become your new current directory. So it's generally a good idea to arrange or document your files in the current directory. So we are going to build our first program. I've taken a very simple example where we try to calculate the area of a circle or a circular object of radius 5 centimeters. Now, MATLAB has these interactive code editing tools that we've made mention of, the line numbering and then the warnings. So we see some of them here. When we type this out, we'll realize. And so let's attempt that. So we close demo, we go to new script, and then we save. Very important. We call this area. Now the extension here, the default extension is the .m file, and that is what you want to save it as. There are other options, but this is what you want. It's a text file, .m. So you just save it as such, and then you have area.m over here. That's confirmation that your file has been created. Now we have r, which is our radius. So maybe let's call it radius, and that is equal to 5 as the number. Then we will place the suppressor over there. Now, next we calculate the area. So let's call it area, which is pi radius squared. So this should give us the area of whatever shape we are dealing with. And we want to see the area, so we just leave this one. Without the suppressor. Now we begin to see a few things over here. So we see something highlighted in red or underlined red, and then we see something highlighted in yellow. And when you come to the right side, you notice that we have some messages here, and there's a prompt here telling us an error has been found in our code. So let's try to fix this one by one. When we come here, we hover over it, we get a message, add a semicolon after the statement to hide the output in the script. So this is just telling us to bring the delimiter or the suppressor. And once we do that, it goes away. So that's a warning, and that's because if you didn't place that there, your code will still run successfully with no internal problems. This, on the other hand, is an error, and you realize due to the red indicator. I'm going to bring back the warning by deleting this, and then let's try to fix the error. So this is coming because we have our script named area, and then we've created a variable called area. So there's a conflict. MATLAB does not like this. That's one of the variable naming rules when you're dealing with scripts. You cannot name your script after a variable in your code. So let's go capital A, like for area. Let's use a symbol. And then we realize that the error goes away, and now we are left with a caution or warning sign. It's telling us that a warning has been found, and then it's giving us an indication to the exact line on which the problem is and what the exact problem also is. So we terminate that, and then it all goes away. However, we do not want to terminate that yet. We need the results shown. Let's try that first and see what happens. So once you are done, if this is all you want to do, you can now come here and then run. And this runs every section of your code. When you have different sections, code sections, you can use run section. So let's just go ahead and run. There's also a shortcut, which is F5. You can hit on your keyboard to quickly run your program. So I'll hit on run, and then realize over here that the program did run. So you see this over here. And then when you check in the workspace, you realize that there are values for A and radius. However, you do not see any output here because we suppressed the output. So that's why I didn't want to do that earlier. So when we run now, we get the output. Area is 78.5398. So that is our first program. This is a program we've saved. Anytime we need to use it, we can quickly access it. Even if we shut down our computer, when you open it, the file is always going to be there. You can just open it and then run this again. Now, this is a very simple program, and even as it is, there are a few problems to note. The first thing we notice is this script lacks generalization. Now, one of the main uses of a program is that if you found a way to do something, you'd want to be able to use that method for any applicable scenario. So if you found a way to determine the area of a circle, if we knew the radius, then you want to be able to determine that area for any radius that comes. So basically, a good program should allow input. A good program should be general, should be generalized for all scenarios or all applicable scenarios, and that significantly increases the utility of the program. So if you create a program that can only calculate the area of a circle if the radius is 5, it's not very useful because there are very few instances anyone will be looking for that particular instance, right? Generally, people want to be able to estimate the area of a circle given any radius. Then in that case, you have more people having utility for that program. Now, aside that, the program output is bland and not flexible. So that is another problem. We cannot customize or we cannot seem to produce outputs choosing. It would have been nice to be able to display the area is 78 point whatever. We may have even wanted to format the answer produced, or we could have wanted a message pop-up that tells us what the area is. So these things are all convenient features, especially when you're building user interface programs where that interact a lot with a user. You would want these convenient and highly interactive functionalities. Right. Then our last problem is the absence of proper documentation. So that is just a coding recommendation. Important to document your code, and that one helps you to track what the various sections of your code is doing, especially when it's very long code. And then when you also pass it to other programmers, especially when you're working in a group on a large project, people are also able to quickly understand what your code means, and they're able to fill in whatever they are supposed to do as well. So these functionalities are going to be our focus for the rest of this lesson. Rather, other than that, we would have simply done that because every computation we've done previously could be done in a script. It's just a matter of repeating the same thing and then storing it. So really, scripts, the main difference there is that we are now storing the computations or the algorithms we use for those computations. We are not storing them as programs. Now, generally, for a good program, a good program should allow a user, or it should be able to get inputs, right? So a basic algorithm needs to be able to fetch inputs. Now, the inputs can come from different sources. It could come from a user entry. It could come from a data set or a file that's read in, among others. Now, after that input is taken, the file or the program then uses that input, goes through the algorithm, and calculates or evaluates your results, and then it displays it. So the user sees what the output for that input is. Now, as we've already stated, it's recommended to appropriately document your code. So we are going to automate our area script so that it accepts any radius given. Right? And to do that, we move to input and prompting in MATLAB. Now, MATLAB has a number of ways, as we say, for collecting data. And there are usually functions that have a placeholder for a value or some kind of input. Now, for us, we are going to take or tackle the input function, and then the input dialog function. The other type lists basically taking a preset um, selection of items. So you scroll down a list and then you choose a particular, there's yes or no prompts. So for taking different kinds of inputs from the user. So the variable or the syntax for creating an input prompt is just that the variable that is going to be used, in this case, a radius, which is what we need from the user, or we need in order to estimate the area. We are going to take from the user using the input function. So this is the syntax. Now you need a prompt, and then you also need the input function. So it just has two parts. This is the input in typical function form, function name, and then the argument. right, inside the parentheses. Now there's the prompt message, which is you telling the user what they need to enter. So the input is just that simple. So in our case, the radius or R equals input, and now we want the user to enter radius, right? Enter the radius. So we just prompt them to do that. So now radius equals input. We're just going to edit this. And then we bring quotes. So we go ahead and tell them to enter the radius in centimeters. Then we show them where to enter. And then you close parentheses. And that's it. Until this now, if we were to run this, we see in the command window that instead of directly getting the area, first let's ensure that anytime we run this, our previous results are cleared. So let's place clear on top here, and then let's add CLC. So first let's do this first. Good. So after we run the program, it's asking us to enter the radius in centimeters. So in this case, it was 5. It's that, and then it tells you what the area is. So now, anytime we run the program, it asks for radius. We can put in 10. It will give us the corresponding area. Could run this again. 60. We get the area accordingly. So that is the first part, or the first step into making or improving our code and making it more interactive. Now, the goal here is to understand how MATLAB goes about the computation. Remember, we stress on understanding code structure rather than memorizing syntax. So what is happening here is this input function, right, essentially creates a placeholder or a template for a user to enter a value. So that is what happens. MATLAB tries to access, after all of this, MATLAB first tries to get the value. Remember, it goes from top to down. So it clears the command window, and then it tries to get radius. So what is radius? It comes here and then emits an input function. Okay. So what is the argument of the input function? It does not know yet, so it creates, you come here and get the prompt, right? The inputs create this prompt and ask you to enter it. So at that point, the program pauses, waiting for the user to enter the radius. And right after it's entered, you hit enter. That value that the user enters is now assigned to radius. So that is where the variable assignment occurs. Now, at that point, MATLAB now has the value for radius. So it moves on to the next line, and then it's being asked to find area, or A. So it comes in here, pi, okay, it has the radius, and then it evaluates A. Then you have the display on the command window. So that is essentially what's happening. It's very simple. Now let's move to input DLG. So DLG is very similar to input. It just has more functionalities. So input is very simplistic. It's not good for complex programs that need multiple inputs of different kinds, that needs to default values, that needs to provide user guidance for inserting values or entering the input, right? So that creates the need for input DLG, or that's where input DLG comes in. Now it opens a GUI. There's a graphical user interface dialog box with a number of labeled fields, right? So they are just templates where the user can enter the expected inputs or values. Now, input DLG returns an array of strings. So it returns a string. If you remember what a string is, it returns strings. So the output of input DLG is a string. It's not a number. Now, typically after you run input DLG, you would have some code at the subsequent, right? So if we come here, after our input, we had some program that was supposed to use that input for computation, and numerical computation. So what happens is, if whatever is passed, this 60 is interpreted as a string. Once that is passed to this function, we are going to run into a problem, because we are trying to square a word or a characters and MATLAB cannot do that. It expects a number. We need a numerical value here for this computation. So anytime you use input DLG, you need to convert your values to your strings to values, right, numerical values, and that is done using the string to double function. So this is just string to double conversion. So that accepts a string and then returns a float. And so remember what a double is, a floating point, double precision decimal. So let's do that. So first input DLG instead of input. I'm just going to edit this. And then we keep that as such. And then we come here. There's string to double. So one thing to note here, let's talk about this before you even proceed. Now the variable here we created is radius, right? And that's what's used in a computation. Now, when we enter that, we need to pass radius to straight to double, the string to double. So no, that's just what we'll do here. We are just going to pass radius to it. Now, this should not be a problem. We need to assign this also to variable, sorry. Now, this may look a bit confusing, but let's remember how MATLAB works. The first thing that is run is this. The user, it pauses waiting for the user to enter the value. The user enters the value, it assigns that value to radius. Now it comes here and emits radius again. Now remember how MATLAB works. The code is entered dynamically. So at this point, it has a value for it. So it tries to assign a value to this. Okay, what's that value? It's a conversion of a string to a number. So it comes here. What is that string? That string is assigned to radius. So it doesn't know what string that is, yes, because that string was assigned to the radius variable at this point. So it reads that string, converts it to a double, and then assigns it to radius, this radius here. Now, because this is the latest declaration of radius, this is the value of radius at this point, right? Whatever what happened here is now converted to this. So now this is what radius is. So this will still work. And then when it comes to the next line, it has radius here that it needs in order to compute the area. It's going to take this value of radius because this is the last or the latest variable assignment. However, the right way to do this, it's better to avoid redundancies. So let's call this prompt. And this is not actually where the radius is. The user enters something, but it's not the numerical value of the radius. When the user enters this value, it's read in as a string. So there's the prompt, and that's sent to the user. And then after the prompt, we convert whatever the prompt got, or the output of that prompt is converted into a double precision decimal and assigned to radius. So now this is where we have the radius. So let's terminate that nicely. And then that radius is now used to calculate the area. So let's run this. So once we do that, we get a dialog box asking us for the radius in centimeters. And then we can enter that radius. Say the value is 1, hit OK. And then you get your area. Such. So that is basic input DLG. Now, there are more functionalities. The full form is actually input DLG. There's prompts, title, dimensions, and defaults. So the prompts are your entries, right? And the prompt, this form allows you to enter multiple values. So maybe you needed more than one variable to calculate your parameter of interest. For instance, if we're estimating the volume of a cylinder, we would have needed both radius and height. So the prompt in this case would be able to accept both the first value, which may be the radius, and then the height. Then we can title our dialog box using the title command. We can then specify the dimensions of the entry fields. So the first entry, 145. So how many rows? So the dialog box we obtained when we ran this. This is one row. If you specify two, it doubles the height of this. It just adds another row to it. Now the other dimension is the width. So in this is 45 units. Right? If you increase this, the length of the dialog box will increase. Then we have default values you can assign so that if nothing is even entered, those ones are used. Or they also give the user an idea of the kind of values they should enter or they're expected to enter. And then you finally call the inputs DLG and then pass all these structures to it. So the full form is slightly sophisticated, but it's simple to use at the end of the day. So subsequently, when we build more programs, we will use this type, and then we'll exactly see how it is done. Now, after input, so that is it for inputs. You have the input, the simple input, and then the input DLG. Now, after input, we need conversion. We've realized that some of the input forms, depending on what is entered, you need conversion. So if you use input, one thing they mentioned, if you use the input command, let me cancel this. If you use the input command without a DLG, you can enter more than numerical values by specifying. So if you have a string, you can specify here that what you want to enter is a string, and it will allow you to do that. Exactly. So there's more than one form for input. So in those cases where you have character strings being returned, however, math operations cannot use strings, you obtain an error. So let's try that. Let's use input DLG for instance without forget about this. Let's use input DLG without the conversion. So let's just comment this out. Now after commenting this out, we do no longer have radius defined as a variable, so we need to change this back to radius so that radius is directly assigned. Then we have radius there defined. That's fine. Now let's run this. So we enter. So this is confirmation of MATLAB's line by line execution. Even though this would return an error, it waited until it got to the exact point where the error would appear before prompted us. So if we notice this line is perfectly fine and it was run, and that's why we received the dialog asking us to enter the value. Now after that, we gave it the value. However, it read it in as a string. Right? It takes it in and then converts it to a string, or the output from this is a string. So whatever is assigned to radius at this point is a string, and a string cannot be used in mathematical computation. So once it gets here, it's not able to square whatever radius is, and then it encounters a problem. So that is why we need this line. We need radius. Then, so if we wanted, we could, this was just to make sure that we document our code nicely, but we could have gone string to double directly. Right? We just nest this inside the string to the double function. And then once we run this, that error goes away. So this converts whatever input DLG was given to input DLG into a double. And the double or the decimal can actually be used for computation. So we obtain the right answer. So let's just sort this. Well, let's go back. So this was prompt. And then we had radius here. So this is fine at this point. This runs and gives us what we need. So a lot of things can be converted. And aside converting from string to double, we can convert from string to num, double, You can convert from number to string, and among others. You can format a number to a string as well. Okay. Now, some of them are recommended and others are not. So this is usually the most useful form we'll be using as we move on. Now let's talk about output tools. So there are a few or a number of output tools we can use to have control over the nature of the output we obtain when we run programs or when we create programs. Now in this lesson, we will look at display, fprintf, and then message box. So display is the first one, is very simple, or the simplest way to uh, obtain output. So the first form is just a string, right? You can tell it a MATLAB display this. So let's try that out. We have the area. We can tell MATLAB to display calculation complete. And then when we run this, regardless of what happens, we get calculation complete. So that is one way. Another thing we can do is to print the variable, the output variable. Right, so instead of this, we can go display A. So it's okay, but let's first limit this. Let's suppress this so that only the display comes out. So when we hit this, it just displays the variable A, the value of the variable A. And then we can also display vectors. Maybe we have multiple variables we want to print out. So we could have decided to print out maybe A and its radius, or the radius in the area. We'll pass it as a square, and square braces as a vector. And then we obtain that the radius is 10 and then the area is this value. So that's essentially what display does. Now, it's a very limited output tool as far as output tools go, and as such, it's not used a lot compared to the next one, which is fprintf. So fprintf allows formatted output to be printed to the screen, and so it allows more formatting. And the syntax is also fprintf. It's a function, so it takes in arguments. Now, the first part is a character vector, right? So call the format specifier, or the format specifier that way, which contains a character vector. So what happens is you are able to specify words or characters, and then you're also able to create, place a placeholder for the value of interest. So in this case, for instance, we calculated the area, and then we may want to report something more fancy. Maybe we want to say fprintf. We want to say the area of this shape, or let's say circular object is. And so this part, it's text, and this will be printed in our output. Right, so if this is all we wanted to do, so the two main parts that now we need a placeholder. A placeholder is exactly where the value will be placed. So in this example, for instance, the answer is %f. Now this %f is the placeholder. So it specifies the format of the output. So we could go %f, %d, there are a number of them. And then the actual variable whose value is to be printed out. So the value of that variable. And then when we run, we enter this, we get the response. The area of this circular object is 314, whatever, right? Exactly as we specified here. So %f just tells it, one, this is where to place the value, and two, it's a floating point decimal. Right? So we could specify more things. If we added dot 2f, that will tell it that it should be a 2 decimal place floating point. So we could do that. And then realize that after the decimal point, you just have two places, right? Decimal places. So we could format. So that is why it's called a format specifier. This allows you to specify the format of the value you obtain. So we can add more. Let's add more stuff. Let's say we want this, the area of the circular object is, and then we want everything that comes after it to be on a new line. So we just, whatever point we want the new line to start from, we just go /n at that point, and anything that comes after /n is going to be moved to a new line. So we're going to say this value, and then I'm also going to specify the units. So let's say square centimeters, and then let's run this. So we see that the area of the circular object is 314.16 square centimeters. So that's f.f. It allows you to carry out more formatting functionalities, or use more formatting functionalities. Now, aside the simple form, you also have the version we looked at. You also have different versions. You can specify as more than just a decimal float. So %d is an integer, %2f, %e scientific notation, and among others. So n is new line, t insert a tab space. So let's try some of these out. Let's go %d. So this just reports in scientific notation because the original value is not an integer, it's a decimal or a float. So let's try E rather first. Right, it just reported in scientific notation. So what we could have done is we could have rounded it before this point. So let's do that. Let's round this. So the round, you can just use the round function. So round all of this, comma. So this is just the argument, right? Round this, and the number of decimal places. We want a whole number. So let's put 0, right? 0 decimal places. So that should give us a whole number. And then, so let's run that first and see what happens in scientific notation. Right, so this just tries to report it's still in scientific notation, but we realize that every other thing is truncated compared to what we had before. Right, so if we change this to 2 decimal places, we see that the other numbers are brought on now, or added to it now. So let's go back to 0 decimal places. Then we run it. Before that, let's move from scientific notation to integer. Now let's run that. Then we get the integer. Now, it's not actually an integer in here. We've just used rounding to make it an integer, essentially present as an integer. But in MATLAB, it's still considered a double. If you come here, you can see that it's still considered a double. So if we wanted to actually change it to an integer, we need to use a conversion. But remember, this is just I print output. It's not creating any variable. So even though it's converted to an integer here, it's not assigned to any variable. So we cannot access that and verify that in the command in the workspace. So let's go back to what we had earlier. We just have our area. This should be, so let's go to the decimal places. Now, aside f.printf, there is also an alternative form called s.printf, and it just runs the same thing, but it converts everything into a string. So the entire output is a string. Now, that in and of itself is not particularly useful, but in cases where you need to pass this print out to another thing or another function that requires a string. For instance, the next one we are going to look at, then this becomes useful. So just keep in mind there's also sprintf. We can run this, and then we see that it's placed inside these quotes. It's for our strings or character vectors. So just take note of that. Now let's move on. So let's talk about the message dialog box or MSG box or message box. So for user programs, if you want more interaction, you can use a message box to display a pop-up message rather than printing it in the command window on the screen. And that's useful for programs that are not even going to run with a command window. You will then need to use a message box or some sort of a pop-up tool to print messages to the screen for users. So the key thing or issue with message boxes, it only takes string arguments. So you cannot use it the way fprintf is used. Therefore, if you have your arguments as fprintf, you need to convert whatever fprintf is bringing out to a string. So in that case, you use sprintf rather than fprintf, and then you pass that to the message box. So just as we did for fprintf, right, this is what we did earlier, but we just make this s, and then we give that to message box as a function. So let's go back to our code. We've already done that. So we had this as fprintf instead, and then that was giving us the area. Right, I'll just run this once more. That was giving us our area. Now, if we want a message box, can come down, say msg box, open parenthesis, and then specify what the prompt is. So I could go, maybe let's create another variable. So we see the utility of variables here. So let's say that is f. Pass f to this. Let's press f, and then we run. So 10. We should expect an error, and that is exactly what happens. So it says expected an input to be one of these types, char, cell. Instead, it was double. So it's complaining about the nature of the inputs from this point. This is a double. The answer from A is a double. So it doesn't want that. So if we quickly change this to sprintf, that should now be fine. And then we get our pop-up telling us what the area is. Right. So instead of being displayed in the command window, we obtain a pop-up. So that is it for our program. The last thing we want to do, which we spoke about earlier, now we have a program that gives us the opportunity to enter radius, any radius we have, calculates the area for us, and then presents it in a message box. Now, we spoke about documentation and need for documentation. So what we can do is write at the beginning, we create a comment, you comment your code, and then say this estimates the area for circular object, no radius. So let's say this program. Then at every point I could use the user entry prompt. So this will be some sort of appropriate documentation for the code. So you do this as you go on. It doesn't always have to be this detailed. I just did this version so that you can see what it looks like. And anytime anyone looks at this code, they are quickly able to tell, first of all, what the program does. They're also able to tell at every line what is happening. So it's a great thing, especially if you're going to be sharing your work with other people. It's great to document things that can easily be um, misconstrued or misunderstood. And in the next part of the lesson, we will tackle more detailed programs. We'll look at bigger programs and then take a dense version where we use the full form of some of these tools to build a larger program. Now we will be using more tools, building scripts. This is the simple part of building a program. So this is a very simple program. I could close this and then just return to original MATLAB. And then anytime in the command window, I can just run this and the program is run. So if I can just start MATLAB from scratch and then run this. And if I enter the radius, I get the area, right? So I could have so many program files in there. When I come here, if I'm looking for my area calculator, I just call it and then input and then get my result. So this is a simple program. The programs we'll be dealing with from this point on will be more complicated, involve more lines of code, and we'll be doing bigger stuff. And then we would embed other tools we build on from this point. So when we look at loops and conditional statements, we'll embed all of those in programs. So this officially brings us to the end of working in the command window. We will be building programs from this point on or onwards. Now let's demonstrate live scripts. So I'm simply going to copy the code from this file so that this is quick to demonstrate a live script. So let's save this. Let's call it live script area. So I ran this for the first time. It asks me for this. And then it gives me the result. So we note that the output is also presented here. And this is what we're talking about. So this is a bit limited in terms of outputs, but when we are dealing with other types, when you have plots and so on, you see how quickly things get updated over here. So it's a matter of preference for people who would like to see results as they work, as they move on. This can be a great tool. However, in our particular case, it's limited because we have this user input thing here, right? So we still need to run and get this before the live script works. So there's not a great example for using the live script, but this is how to create one. Right? It's simple. It just shows your results side by side, and it does that as you code. So as you add more things, it just shows you the result. So when we get a great example that has several parts, and we want to show some of the great formatting features for live scripts, and its in-situ results behavior, we will demonstrate that. However, for our lessons and our work, we will build programs in actual scripts, right, in the real script files like these, and then run them when we need the results. That brings us to the end of this lesson. I'll see you in the next one.